Okay, if you exert 14 meter newtons through 3.1 rotations on a potter's wheel, that is a 26 kilogram, 68 centimeter diameter uniform cylinder, what will be the final angular velocity, assuming it starts at rest? The initial is angular velocity is 0. That's an omega. Okay. Well, let me show you how to do this, right? Well, let's use the work energy theorem, right? Work is going to become rotational kinetic energy. Okay. So our work is torque times angle, and then that's just simply going to become 1/2 I omega squared, right? Now, 3.1 rotations, we got to turn that into radians, right? So 3.1 rotations times 2 pi is 19.48 radians roughly. Okay. And then otherwise, we need to find the moment of inertia too, don't we? Okay, let's do it. Moment of inertia. It's a uniform cylinder, of course, right? So 1/2 mr squared, 1/2 26. What's our radius? Is it 0.34 meters? There we go. So 0.5 times 26 times 0.34 squared is 1.5028. And that's kilogram meters squared. So now we're all set. Let's use work. Torque times alpha is kinetic energy, right? So torque is 14 meter newtons times our angular displacement, 19.48 radians, is equal to 1/2 1.5028 times omega squared. Now, you might say, is this easier than Suvat? I think so. Well, is it? I don't know. Suvat, you could Suvat this, right? Figure out the angular acceleration of it and then Suvat that to find this. You would still have to do this calculation, that calculation. Yeah, I guess it's about the same. Oh, no, one more. You'd have to figure out the acceleration, then you could Suvat it. One more calculation. Okay, so let's go 14 times 19. It's actually 19.47787, right? Okay, and then I'm going to multiply by 2. I'm going to divide by the moment of inertia. And now I've got omega squared, and then I'm going to square root it. 19.05. 0.01 or something like that, and that's radians per second. So is that a better way to do it? It's just another way to do it, right? You could have done this. We could have done this. Here, we'll do it a different way. I could have done this with acceleration, right? So torque is I alpha, right? We could have looked at this as an 8.2 problem, right? So our I is 1/2 26 times 0.34 squared. That's 1.55028 squared, right? Our torque is, well, we already know that's 14, right? Meter newtons, right? And so we can now find alpha. Alpha is just 14 divided by. So alpha is 9.3159 radians per second, right? Squared. All right, and now we could Suvat this, right? So let's say it starts from rest. Doesn't say, but let's say it's 0, right? Final velocity is what we want to find. Our acceleration is 9.3159. And then our displacement is 3.1 rotations. So let's turn that into radians. So times 2 pi. That's 19.48 roughly radians. Okay. Okay, so now we got to find the final velocity. I'm going to use v squared. is u squared plus 2as. Okay, so v squared is 0 squared plus 2 times 9.3159 times our displacement 19.48. All right, so I'm going to go square root of 2 times that guy, the 9 point whatever, times 19.477. And I get exactly the same thing, 19.05 radians per second. So you could do it either way. Is this easier? I don't know.